Good day everyone. Today I will presenting on candle wax for lighting purposes, its composition, characteristic and application. So candle wax is a crucial material in the production of candle, especially those intended to provide light. Unlike scented or decorative candles, lighting candles are designed to produce a stable and also bright flame. They are commonly used during emergency or in spiritual rituals or in areas without reliable electricity. The type of wax used in this candle play a significant role in their burn quality, duration, and overall safety. Based on the table, I will explain first about paraffin wax. It's the common widely used wax of lighting candle. It is a petroleum-based product made up of long-chain saturated hydrocarbon. The advantage of paraffin wax include its bright flame, affordability, and availability. To improve the quality and stability of paraffin candles, styrene is often added. Styrene is a fatty acid that can be derived from either animal fats or vegetable oils. It is helped to harden the candle, making it more durable and less likely to burn or melt in warm conditions. Styrene also increases the candle's burn time and reduce dripping, which is very important for candle used for lighting. And beeswax is a natural product made by honeybees, and it is composed of ester, fatty acid, and long-chain alcohol. One of its main benefits is that it's burned very cleanly, producing minimal soot and a pleasance, and also it has a natural scent. Beeswax candles burn slowly and produce a bright and also steady flame.
Our GCMS analysis revealed that the candle wax is primarily made of long-chain alkanes, branched hydrocarbons, and fatty acid esters. This composition suggests that it is mainly paraffin-based but also includes natural additives characteristic of modern blended candle waxes. Long-chain alkanes such as tetraconcane, hexatriacontane, and tetracontane are saturated hydrocarbons with a carbon chain between 20 and 40 atoms. These compounds also high melting point. They are responsible for the firm structure of the candle and contribute to a clean, steady flame. These compounds have strong intermolecular forces with strong van der Waals that making them solid and waxy at room temperature. The sample also contains branched alkane like 2-methyl-tetraconcane and 3-methyl-pentaconsane. These are often added to reduce brittleness and improve flexibility. Because of their irregular structure, they make the wax softer and help it melt more evenly. It also lowers crystallinity and enhances melting behavior. This results in a better burn quality and improved scent diffusion. We also found compounds like palmitic acid and glycidyl palmitate, which are derived from natural plant oils such as soybean, palm, and coconut. These fatty acid components not only improve the wax smoothness and scent retention, but also reduce soot and contribute to a cleaner, more environmentally friendly burn. In summary, this wax is a hybrid formulation combining petroleum-based paraffin with bio-based material. This blend balances performance and sustainability that resulting in a candle that burns efficiently. It looks appealing and meets modern consumer expectation.
Based on the FTIR analysis, there are several key peaks were identified that helped determine the composition of the candle wax. So firstly, strong peaks at 2920 and 2850 cm corresponds to the CH2 stretching vibration, which are typically of long-chain hydrocarbon, a clear indication of paraffin wax. So this result is consistent with the findings reported by Kasprzak et al. 2021, which I show in the figure 1b, and Nunes Garcia et al. 2022. And then a sharp peak around 1700 cm indicates C-double bond O stretching, specifically from carboxylic acid groups. So this peak was also observed in commercial candle wax by Kasprzak et al., suggesting some oxidized components may be present. And then at 1470 cm, we see a medium intensity peak attributed to the CH2 scissoring vibration, which confirms the presence of methylene group along with the hydrocarbon chains. The peak at 1370 cm is associated with CH3 bending vibration, which indicate metal groups at the end of the chains. This suggests that hydrocarbons have a defined structure with clear chain termination, as supported by Jahangiri et al. 2024. And then another strong peak at 720 cm corresponds to CH2 rocking vibrations, which are characteristic of crystalline long-chain alkanes. This support identification of structure paraffin wax as seen in Yadav et al. 2024. And lastly, the peak at 1175 cm indicates CO bond stretching, suggesting that presence of minor oxygenate compounds, which possibly due to the additives or mild oxidation. So this aligns with the FTIR data from Yadav et al. 2024 on paraffin-based composites with esters or stabilizers. So, as conclusion, overall, this result confirms that the candle wax is primarily paraffin-based, but not entirely pure. It likely contains small amounts of additives or oxidized products, which is common in commercially formulated candles. Thank you.